Thank you for joining me today, and welcome to my physics walkthrough video. So today we're going to be taking a look at a problem that I think we can all relate to, and uh, and I think is a very interesting one to solve. So the question is, a person with a mass of 66 kilograms stands in an elevator. The elevator starts from rest and accelerates at a rate of negative 2.24 meters per second, or meters per second squared. You should assume the upward direction is positive and the downward direction is negative. What is the contact or normal force of the elevator floor in newtons acting on this person during this period of acceleration? So let's go to step one. So we have to determine our known values. This is extremely important in any problem, and this is no different. So first off, we see that our mass is 66 kilograms. Fairly standard, just something to note. Acceleration, negative 2.24 meters per second per second. So I see it a lot, and I've done it myself, where we drop that negative and all of a sudden our value is completely wrong. We have to make sure that we account for that negative throughout the project or the whole problem. And then another interesting point that a lot of people miss is that the upward direction is positive. This is actually important data for the question. If you don't align yourself with how the question wants to be answered, you'll get a wrong answer. So now that we have our known values, let's jump to step two and actually determining what we're trying to find. As we saw in the problem, we're looking for what the contact or normal force of the elevator floor is that's acting on this person during the acceleration, right? So how would we go about that? Let's take a look. In step three here, we can see that we are supposed to determine the overall acceleration that the person is experiencing. We need to do this first before we can go on to actually find the normal force. So to determine the overall acceleration, we look at gravity plus any additional accelerations, and that's it, right? So we take our 9.8 for gravity, simplified a little bit, plus our negative 2.24. Make sure you don't lose that negative, and you get 7.56 meters per second per second. And if you have a keen eye here, you'll notice that I forgot to make per second there. But don't blame me too bad for that. You get the point. So let's move on. We look at 7.56 meters per second squared. We can now find the normal force provided by the floor. So this is just a simple F equals ma problem. Force, normal, equals mass times acceleration. We take a look at our first, we plug in our mass, and we plug in the acceleration that we found in the previous slide to get 498.96 kilogram meters per second per second. It may sound like a familiar unit to you. That's because that is equivalent to newtons. So we were at 498.96 newtons. And actually, that's our answer. Just as easy as that, we're able to find the new normal force that the elevator floor is applying on the person's feet. So that's it. Not too hard, but super interesting, and you can think about that next time you're on an elevator.